All right, we're talking about Chapter 2, Section 7. We're talking about one-to-one functions and also inverse functions. And the first thing we want to do is we want to start off, what is a one-to-one function? So a one-to-one function is a type of function. So a one-to-one function, a function is one-to-one if whenever you have f of x2 not equal to f of x1, whenever we have x2 not equal to x1. So the way to describe that is, another way of describing that is, if this y value equals that y value, then those 2 points must have been the same point. The way I kind of describe that is this is an example of a function that is not one-to-one because I have two different x values. I've got an x1 and an x2, and notice that they've got the same height, therefore it's not one-to-one. So for each x value, I have to have one and only one y value, but also for each y value, I have to have one and only one x, and this y value has two different x's, so therefore it is not one-to-one. What this does is allows us to do kind of similar to our test for something being a function, the graph being a function. We had the vertical line test. So if we drew a graph and it passed the vertical line test, then we knew it was the graph of a function. If any vertical line intersected that graph at most once. Well, we have a similar thing now for horizontal line test. This is to see if a function is in fact one-to-one. Well, a function is one-to-one if and only if no horizontal line intersects the graph more than once. So I've got three examples here. We can take a peek at them. First one is, this is the graph of, say, x squared plus 2. It is a function. It does pass the vertical line test. If I take any vertical line, it intersects the graph at most once. However, if I do have a horizontal line, notice that if I can find a horizontal line that intersects the graph more than once. Hence, this thing is not a one-to-one function. Okay, so if you can find any horizontal line that intersects the graph more than once, then it's not a one-to-one function. Here, this is a function. Again, it passes the vertical line test. Is it one-to-one? I say yes, because no matter what vertical line I draw, no matter how many or any horizontal line I draw, how many times I draw one, it touches the graph at most once. Hence, it is a one-to-one function. Last one. So these are both yes. These are one-to-one functions. Last one is kind of a trick question. I'm asking if is it one-to-one or not. Well, it's one-to-one if to be one-to-one you have to be a function. This isn't even a function, so we don't talk about one-to-oneness unless we have a function. This doesn't pass the vertical line test, hence it's not a function, so we don't even talk about one-to-one. So although you might say, hey, look, if I draw a horizontal line, it touches at most once. Well, we don't talk about one-to-one unless it's a function, and in this case, this one's not a function. Okay, continue on it. If I have a one-to-one function with domain A and range B, then we can talk about its inverse function, f inverse, which has domain B and range A, and is defined by the rule f inverse of y equals x if and only if f of x equals y for any y in that area B, in that set of values B. So an inverse function, basically what it does is think of it as it undoes what a function does, okay? And they only exist if your original function is one-to-one. So right here, let's take a look at this one right here. This is a function, right? 3 is assigned to 4, 7 is assigned to 2, 5 is assigned to 6. 3 is only assigned to 4. 3 is not assigned to anybody else. 7 is only assigned to 2, nobody else. 5 is only assigned to 6. Okay, so I've got this function. The question is it one-to-one? Well, it's one-to-one because I don't have 4 being assigned from by 3 and 4 also being assigned from by another number. In other words, its inverse is in fact a function. That is to say, if I look at f inverse, okay, f inverse, if this is f inverse would be 4, 3, 2, 7, and 6, 5. So notice that its inverse is in fact a function. 4 only has 3. We're interchanging the x and y's. 2 only has 7, and 6 only has 5. So think of it this way. What f does is it sends 3 to 4, and what f inverse does is it sends 4 back to 3. Okay, and so we go through this, and you kind of see that again. 3 goes to 4, 4 goes back to 3, 7 goes to 2, 2 goes back to 7, 5 goes to 6. F inverse sends 6 back to 5. Now, whereas this one had an inverse, this one does not have an inverse. The reason it is because it's not one-to-one. It doesn't pass that horizontal line test, because you can even see that if I graph these points, right, 9, 1, right, 4, 7, 4, 7, okay, 6, 1, 1, 2, 3, 4, 5, 6, 1. Now all of a sudden it doesn't pass that horizontal line test, so hence is not one-to-one, so we can't even talk about its inverse function. And you'll notice that its inverse isn't actually a function, because you have 1 go to 6, but 1 also goes to 9, and that's a problem. Okay, so this one does not have an inverse, whereas this one does. Now again, what the inverse does is it undoes what a function does. So if you have a function that's one-to-one with a domain A and a range B, then the inverse function, f inverse, satisfies these two cancellation properties. Okay, so think of it as f inverse and f are canceling. So you get back to x, and that's true for all x in A, and we're talking about the domain, which is of f, which is A, and here the domain of f inverse is B. So for any x in B, f of f inverse of it is just simply your number x. Again, think of a function's inverse as undoing what a function does. Okay, so let's talk about how to find an inverse function. Well, the first thing that you do is you substitute, given a function f of x, you substitute y for f of x. After you do that, you solve for that y value. The way you solve for that y value is isolate y, put everything else on the other side. And if it's already in that situation, that's great. What we want to do is then Okay, now let's talk about how to find a inverse function from a one-to-one, given a one-to-one function. First thing you do is you substitute, given f of x, you substitute y for it. So wherever you see an f of x, you write y. Second step is to interchange x and y. That means wherever you see x, you're going to replace it with y. And wherever you see y, you're going to replace it with x. After that, you solve for y, which means isolate y, put y on one side, everything else on the other. And the last thing is we replace y with f inverse of x. So let's kind of do that. I've got two problems up here, and I'm going to kind of go on the first one right here. I'm going to go kind of generally, and then show you how exactly using this process. But I kind of want to understand what exactly is an inverse function with it. Then we'll find its inverse and kind of show. And then the second one, we'll actually just go ahead and find its inverse. So let's just take a look at this. This is a function. It's a linear function, and you could look at. I'm just playing around with it right now. We're not doing the steps just yet. Suppose I put in some numbers. Suppose you put in 2. Well, you get 5. Suppose you put in, say, 8, right? I get 24. Take away 1 is 23. And I'll pick a negative number, negative 4, and I get negative 12 minus 1 is negative 13. So this is x and y, x and y, x and y. An inverse function, what it does is if I'm sending 2 to 5, the inverse function should send 5 to 2. It should send 23 to 8. It should send negative 13 to 4. So if these are my inputs, then my outputs become these guys. Whereas here, my inputs are these, and my outputs are these f of x's. So one way to think about it, and again, I'm just doing it generally, I'm not going through this process yet, is to think about what are we doing given an x. What are we doing? The first thing we're doing, if I put in a number in for x, we put in 2. We got these numbers. These are pretty easy to calculate. If I put in 2 here, what do I do into it? Well, I got to multiply it by 3. So first thing is you multiply by 3. And that gave me 3x, right? That's what you did to compute. Given 2, how did I get it to 5? Well, I put in 2 and multiplied it by 3. And then what did I do? I took that thing and I subtracted 1, right? I subtracted 1. Well, I subtracted 1, right? Put into 2. 3 times 2 is 6. Minus 1 gave me 5. So if I put in 2, it gave me 5. Well, this is going from this component, x, to this first input to this output, 3x minus 1. What if I want to go backwards? How would I undo this? Well, undoing something, instead of subtracting 1, well, maybe we're giving some value x, we're adding 1, aren't we? Okay, the opposite of subtracting 1 kind of is adding 1, that process. So then I get this x plus 1 right here. And then after I take this x plus 1, we want to undo multiplying by 3, which would be dividing by 3. And that would give me x plus 1 all divided by 3. Now let's see if that's actually what's happening here. So suppose I have, suppose I describe that as my inverse function. F inverse of x is x plus 1 divided by 3. Let's take a look. let me put in some numbers and let's see if that's what actually happens. Well, I want to put in 5, 23, and negative 13. Now let's see what happens here. If I put in 5 in here, 5 plus 1 is 6, 6 divided by 3 is 2. If I put in 23, 23 plus 1 is 24, divided by 3 is 8. And finally, negative 13 plus 1 is negative 12, divided by 3 is negative 4. So this is actually undoing what f did. Now, suppose I want to go through this process, though, to find it. I kind of did this kind of holistic, what's happening here. And sometimes, especially for problems like this, it's much tougher to do it that way. A lot of times, it's just easier to go through this 4-step process. So let me kind of show that 4-step process and how you find the inverse for this particular problem. And then we'll go on to the next one. So for this particular problem, let's do this first. Instead of f of x, we write y. Okay? So now we got y equals 3x minus 1. That's what first step is. Second step, interchange x and y. So I'll have x equals 3y minus 1. Third step is solve for y. Solve for y means isolate y. Well, add 1, divide by 3. I get y equals x plus 1 over 3. And then the last step is, where we see y, replace it with f inverse of x. So going through this process allows us to find the inverse quite quickly. Now, this one was quite simple. Let's look at this one over here. It's much more intricate, and the reason it is a little more difficult is because it has, this fraction and this it's really a rational function. Let's take a look at it. First step, replace f of x with y. Second step, interchange the x and y's. And the key thing now is to solve for y. Now, how do I solve for y here? Well, what I'm going to do is I'm going to isolate y, put just y on one side. So how do I do that? Well, I got to get rid of the fraction first. So I'm actually going to multiply both sides by y plus 3. That allows me to get rid of the fraction. So then I'll have x times y plus 3 equals 2y minus 1. I'm going to distribute xy plus 3x equals 2y minus 1. I put all the y's on one side, all the terms that have y on one side, everything else on the other. So I'm subtract 3x, I'm going to subtract 2y. So I have xy minus 2y equals negative 1 minus 3x. Okay. After this, what I want to do is I want to get just one y, because I have two y's here, don't I? So what I can do is I can factor out a y. Y times x minus 2 is negative 1 minus 3x. And then, of course, from here, what I do is I divide by that x minus 2 to isolate y. Those guys cancel. And so now I have y equals this expression. And so I'm actually going to put it over here because I'm running out of room. But instead of y, what am I going to replace it with? Well, I'm going to replace it with f inverse of x. So f inverse of x equals the negative 1 minus 3x over x minus 2. And there we go. So finding inverse functions, if you go through this 4-step process, isn't all that bad.